So far, we have seen how we can calculate the actual time by doing a regression analysis and forecast the demand by doing sort of like a time series analysis. Third, we are doing a classification analysis, and we will try to find out that if that trip is going to be delayed or not. Let's try to look at the problem definition that if the actual time is 1.5 times the OSRN time, right? We will be tagging that as a delay, and the goal is to predict the probability of delay before dispatch, and we are going to do a binary classification on this. So from for data preparation, again the same treatment, convert these four time features into a date time format, get the hour, day of the week, and the cutoff hour by taking by converting it into a date timestamp. And these features should be of numerical type. And delay metrics we would be engineering by taking a difference of actual time minus OSRM time and dividing it by OSRN time. So that is going to give us the delay ratio and delay flag. If this ratio is greater than 0.2, what we just discussed before, that 1.2 times the OSRM, then we will be flagging it as 1 or we or 0. Okay, and let's try to look at what features we can engineer which can help us in making the more accurate prediction. First of all, just like how we did in our forecast analysis for actual time, where we are bucketing all those trips which has less than 50 as a value count into others, and analyzing those categories that way, we would again perform the same operation here, that we'll find out what are the rare groups, and then for those rare group we will try to look at from a summarized point of view, and for the rest of the other source centers where the value count is more than 50, we would consider them as is, right? So um, this cutoff we have encoded into true or false, right? Cutoff factor we have converted into numeric type. Some of the spatial factor, mm, this route distance ratio is calculated by OSRN distance by actual distance to destination. In kilometer is nothing but actual distance to destination, and all this on the data frame, on our original data frame, we will uh, try to look at the lane delay. And how we are going to do that is by grouping the data on the level of source center and destination center, and we will see the average or the mean delay ratio. And once we have for a given source and destination what is the average delay ratio, we will again like put it back to our original data frame by merging it, and so we will have that lane delay uh, value with us. Okay, let's try to look at the data. I'm getting some error. Let me try to fix it. The error is now fixed. So continuing, we are selecting only the relevant features which will contribute to our analysis. We do not want garbage feature to add to our complexity of the model. Before doing the model training, let's have a look at how the data is looking like. And straight away jumping to what all features that we engineered. So after unnamed 25, these are the features that we have with us, which is the trip creation hour, trip creation day of week, cutoff hour, delay ratio, delay flag. source center group, as I talked about, whichever source has less than 50 as the frequency, they are bucketed into another other, and we would be doing their analysis with considering them as a single unit. Same treatment is given to the destination. Then we have the route distance ratio, then distance in kilometers, and mean lane delay. Okay, let's now train our model using gradient boosting again, but this time we are using gradient boost XGBoost classifier as our base model, and features that we are going to have is already selected feature column, and this is the target that we are going to predict the yes and no type. Either if there is a delay, then we'll have 1, if not, then we'll have 0. And we are converting the categorical variable into numeric by using one hot encoder, and finally we are training our um, data on XGBoost classifier with all these hyperparameter. This is the general set of hyperparameter when we try to do uh, prediction, when we try to do a binary prediction. So generally we use these values as hyperparameter, and then finally we make a pipeline where the preprocessor would be all these features, and model is this model, and we are training our model in this line, and graphical representation of same thing. Our pipeline will have some categorical numerical feature. They are going to pass through XGBoost classifier, and below is the accuracy and ROC-AUC result. And we see that overall our accuracy is quite high, 0.9, and even the precision and recall and overall F1 score for 1 is also quite high. So let's try to look at the model interpretation. What are the top features? Since we are using XGBoost classifier, so it is like transform into principal plane. So hence we see F1, F2, all these features over here. Um, we can explore more on these principal features, but um, let's try to look at confusion metrics. So you see that almost all the ones which were delayed, which were the true positive for delayed, we were able to very accurately find and isolate those values. And upon doing this analysis, what business action it can have, right? So imagine a scenario where we have predicted that for this route we would have a high, delay probability. So the action that could be taken is reroute or assign a good driver a priority, assign more driver on priority. For medium risk, we can, just like monitor as an extra action. And for no risk or low risk, we can like proceed normally. So this was about doing a classification analysis, that given this analysis, there is still a lot of room for improvement, and are doing a lot more business on analysis on top of this. But the objective of this video was to give an overall idea that starting from one data set, how we can proceed to fulfill different business questions using different type of analytical tool that we have in our domain.